All right, let's look at the inverse Laplace transforms. It's probably the easiest to just dive right into examples. All right, so we just need to find the reverse process of finding a Laplace transform. All right, so let's look at the Laplace transform, inverse Laplace transform of s to the negative 7 over 2. All right, so first step would be I'm going to rewrite it as inverse Laplace transform of. So I'm going to write it as 1 over, all right, s to the 7 over 2. All right. Then what we need to do is, remember here, a Laplace transform of a t to the a is gamma of a plus 1 over s to the a plus 1. All right, so in this case, a is going to be 5 over 2 because a plus 1 is supposed to be 7 over 2. And what we need is gamma of a plus 1, which is a gamma of 7 over 2. All right, so I'm going to create that. So you have, all right, so you have an inverse Laplace transform. All right, I'm going to multiply by gamma of 7 over 2. All right, then we have s to the 7 over 2. All right, but we can't just multiply by whatever we want. So we're going to actually divide by, and I'm going to put it outside, gamma of 7 over 2. All right, so let's find the gamma of 7 over 2 first. So gamma of 7 over 2 is using the property. It's a 5 over 2 times gamma of 5 over 2. All right. But this is same thing as, all right, I'm going to leave 5 over 2 here. Gamma of 5 over 2 is same thing as 3 over 2 times gamma of 3 over 2. And then we do it again. 5 over 2 and the 3 over 2 is left alone. And gamma of 3 over 2 is 1/2 times gamma of 1/2. Right, so remember that the gamma of 1/2 is square root of pi. All right, so if you put them all together, let's see, 5 times 3 is 15, and you have a square root of pi over 2 times 2 times 2, so that would be 8. All right, so that's going to be on the denominator. So I'm going to just write the reciprocal. So it's going to be 8 over 15 square root of pi, right? Then here, so in this case, a is 5 over 2. So inverse Laplace transform of this guy is going to be t to the a, which is 5 over 2. All right, so this is the inverse Laplace transform that we're looking for. All right, so let's look at the next one. All right, we do the same thing as before. All right, so since we know that the Laplace transform of e to the at is 1 over s minus a. All right, so I'm going to write it in that form. All right, so first top numerator 2 is just a number. I'm going to put it outside. Then you have inverse Laplace transform of 1 over, right? I'm going to rewrite s plus 5 as s minus negative 5. All right, and that way we can find the inverse Laplace transform. All right, 2 is 2. All right, inverse Laplace transform is e to the a, in this case is negative 5, so e to the negative 5t. So e to the negative 5t. All right, so that is the inverse Laplace transform that we are looking for. All right, so let's do the third one. All right, we're looking for inverse Laplace transform of 3s minus 1 over s squared plus 16. All right, so I'm going to rewrite it this way. All right, so you have inverse Laplace transform. All right, I'm going to pull 3s out. So actually, I'm going to pull 3 outside and keep s on top. And we have s squared plus 16 is 4 squared. All right, then you have a minus 1 over, all right, s squared plus 4 squared. All right. So in order to keep the same format, let's see, this one looks like the cosine of kt format. Here, we would like to have a k. K in this case is 4. So what I'm going to do is I'm going to multiply by 4 and divide by 4. All right. So what we get is going to be, right, so inverse Laplace transform, 3 is 3, so I'll just put that. Right, this is the Laplace transform of cosine of 4t. So you have a cosine of 4t, right, minus 1/4 is in front. Right, this is a sine of kt, and in this case k is 4, so sine of 4t. All right, so that is the inverse Laplace transform that we are looking for. Right? So the process is pretty simple. All you have to do is think about the reverse process of finding the Laplace transform. All right, so let's look at the last one. All right, so we're going to do basically the same thing. All right, so we're going to have inverse Laplace transform of, all right, I'm going to pull 2. Then we're going to put the s over, right, s minus, right, 9, I'm going to write it as 3 squared. Right, then you have, I'm going to pull 5 out. All right, then we have s squared minus 3 squared on the bottom. All right, I would like to have 3, so I'm going to put 3 on top, but I'm going to immediately divide by 3 so that we don't change anything here. All right, so we got that. Then we know what to do, so this is going to be 2 times. Right, this guy is hyperbolic cosine of 3t. So hyperbolic cosh of 3t. All right, so you have 5/3 as a constant. All right, this is going to be a hyperbolic sine of 3t. So you have a hyperbolic sine of 3t. All right, so that is the inverse Laplace transform that we're looking for. All right, that's it. I hope that this was clear.